Over the last few years, the AI industry has looked unstoppable. Models keep getting larger, training data keeps growing, and investments now reach tens of billions of dollars. But beneath this rapid expansion, there's a problem few people talk about enough: electricity. On February 5th, 2026, Elon Musk revealed what's really happening behind the scenes at xAI. To bring its Colossus cluster online, the company had to build its own power plant, route high-voltage lines across state borders, and even consider manufacturing key turbine components themselves. While chip production is accelerating exponentially, the power industry is stuck in long approval cycles, equipment shortages, and slow infrastructure development. Musk's conclusion was blunt: expanding AI on Earth doesn't scale. Within the next 36 months, the cheapest place to deploy artificial intelligence won't be on the ground, it will be in space. This shift isn't about a shortage of chips, it's about a shortage of power. xAI's Colossus 2 cluster alone uses 330,000 advanced AI chips. When you factor in networking equipment, CPUs, storage systems, cooling, and backup power, the cluster requires roughly 1 gigawatt of electricity to operate. That's about 0.2% of the entire electricity consumption of the United States for a single AI installation. Even if that power exists in theory, connecting it in practice is another story. Power plant approvals can take years. Grid connection studies alone can last over a year before utilities even decide whether a facility can be connected. Critical components like gas turbine blades are backlogged globally until the end of the decade. For AI companies that need to scale in months, not years, this delay is fatal. As a result, xAI had no choice but to generate its own power. And this isn't just an American problem. Musk pointed out that outside of China, global power generation is barely growing, while chip production continues to surge. Soon, warehouses around the world will be full of AI chips that simply can't be turned on, not because of hardware limits, but because there isn't enough electricity to run them. So Musk looked upward. Space, he argues, removes nearly every bottleneck faced on Earth. Solar power in space works around the clock, without clouds or atmospheric interference, delivering about 30% more sunlight and requiring no batteries. With modern solar panels already costing around 25 cents per watt, Musk estimates that space-based solar power could generate electricity at roughly 1/10 the cost of ground-based systems when efficiency and storage savings are combined. And unlike Earth, space has no permits, no grid coordination, no cooling constraints, and no infrastructure bottlenecks. The economics flip completely. Lower cost, fewer limitations, and virtually unlimited expansion. This isn't just theoretical. SpaceX is working toward launch rates between 10,000 and 30,000 Starship flights per year, each capable of carrying over 100 tons. Tesla and SpaceX are pushing plans to manufacture 100 gigawatts of solar cells annually, optimized for space, lighter, thinner, and cheaper than anything designed for Earth. Musk believes that within 5 years, the amount of AI computing power launched into space each year will exceed the total computing power currently operating on Earth. At that scale, Earth simply cannot keep up. Earth can only absorb a tiny fraction of the sun's energy, and once AI demand reaches the terawatt level, centralized computing must leave the ground. Earth will be reserved for edge devices like autonomous vehicles and robots, while the heavy computation moves off-world. Beyond that, Musk's long-term vision extends to the moon. Lunar soil is rich in silicon and aluminum, making it ideal for manufacturing solar panels and radiators on-site. Chips could be shipped from Earth, while mass drivers launch massive AI systems into deep space at unprecedented scale. At that point, computing power wouldn't be measured in gigawatts, but in petawatts. This strategy isn't random. It's the natural convergence of Musk's 3 companies. SpaceX provides the transportation infrastructure, Tesla delivers large-scale manufacturing, and xAI creates the demand for massive computing power. Together, they form a closed loop that turns space-based AI from science fiction into an executable plan. Earth is reaching its physical limits. Space is not. The future of artificial intelligence won't be built on the ground. It will be built in orbit,